There we go. If I save that, we got a warning, but I think we're good. All right. And this is called round 2025 contest round problem 7, but it's actually puzzle number 11, and we'll see that when we click on the URL. So let's get right into it. Yeah, view problem 11. Part 1, difficulty rating 2. All right, we're starting harder right away. After learning about the effects of the lotus fruit the hard way, you've been extra cautious around unfamiliar objects. What's that surprisingly soothing sound? Sirens ahead. Put your earplugs on. Block them out at all costs. I assume the them refers to the sirens, not to the earplugs. All of a sudden, everyone's scrambling to put their earplugs on. These are special earplugs, though. They can be programmed to alter incoming sounds. Though you'll have to be quick, as some of the sirens' songs are still getting through. Your team springs into action, and there it is. The earplug coordination device displays the configuration instructions. All right. File starts with the current frequencies of a sound in each earplug track. The first number corresponds to track 1, second to track 2, and so on. This is followed by lines in the format X-Y, representing an instruction to swap frequencies in track X and track Y. All right, so it's one-based. So we're going to have to mess around with that a little bit. If you perform all the swaps in order, earplugs should be correctly configured to mute the sirens and enable the communication with your team. The number at the end of the file is the test index. The track of the sound corresponding to the test index is the test track, which is used to verify that the configuration is correct. For example, all right, we have 10 tracks, a blank line, 15 swapping instructions, and then this number at the bottom, which is the test track. Okay. So these are the frequencies before any swaps. I see that. So that just corresponds to this order here. We do the swaps. Test index is 10, which is 45. Okay. So we just look, after we do all the swaps, we look up the number at the end. And I assume we also have to subtract 1, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So Rust has 0-based arrays, and this is all 1-based. So if you wrote it in Lua, you'd be fine, right? But we're not in Lua, we're in Rust. All right, so the first thing I'm going to do is I'm going to change the way we do the splits here. I'm going to do a double new line for the lines, and I'll call it sections. And let's just print out the sections for now, so we can see that we got it right. Sections. Right? Oh, I don't have the input. We won't get anything if we don't have any input. Let's grab the input. This is problem 11. All right, so we see an 88 at the bottom. We see this blank line here with a bunch of swaps. 352 to 101, so it's 100 frequencies. We go to the top, and we can see 1508 right at the top there. So I think we have everything. Yes. Okay, so let's save that. Let's rerun it. All right, so we have the first thing with all the frequencies. We have the second thing with all the swaps. And we have the last thing with the actual number. And I can see there's a new line we're going to have to strip off, I think, in order to do the parsing properly. All right, so let's get all the frequencies into a frequency array. Let freaks equals sections of 0 dot split. Now I can see there's no new line at the end of this, so we're kind of saved from that business. We'll split on a new line, and then we'll map into a freak dot parse. Does it matter? Let's just use iSize unwrap and collect into a vec. And then I should be able to print the freaks like that, and we should see all the frequencies. Let's just make sure we have 15048 all the way to 15895. Perfect. Now the swaps. I guess we could just do that as a tuple. Sections of 1, split on the new line, And we're going to map swap. And this is going to be a little more complicated. Let left, right equals swap split once on hyphen unwrap, and then we're just going to return left parse usize unwrap, and right parse usize unwrap. I guess this is where we should do the subtraction. Let's do it here for now. It doesn't like something I did. Oh, I forgot to close the brace there. Okay. And now if I print out the swaps, we should get all of the swaps. Except it needs to be like that. Okay, so now the first one is 10 to 70. Oops, I meant to click here. 11 to 71, perfect. And then the last one is 44 to 90. There it is, 44 to 90, okay. And then the final number is 88. Oops, let's switch back here. And then let test index is equal to sections 2. I don't think I can do parse like this. I don't think I can do that because it's going to complain about the new line. Let's find out. Yeah, invalid digit. So sections is a vector of string. Can I do a strip here? I don't know. Yeah, there's no strip on stir. Is there trim? There is. Okay. Oh, let's print out the test index. Just so we know we have 88 there. 87, right? Okay, perfect. Now all we need to do for part 1 is to perform all the swaps. So if we make this mutable, we can say for swap in swaps, freaks.swap, swap 0, swap 1, and then println part 1 is just equal to freaks of the test index. Right? Let's run that. We get 42,810. Let's see if that's right. Hey, that's the correct answer. Okay, we did a good job here. That wasn't too bad. Git status, git add source, git, let's remove the test text there. Git commit -m problem 11 for real this time. Part 1. Okay, let's move on to part 2. Difficulty rating 3. You can hear some voices from your team, but the siren sounds are still getting through. It's not enough. Program the earplugs to standard 2. The added complexity might block out the sirens. The captain seems a little distressed. The siren sounds are starting to take effect. The same file can be used to program the earplugs to standard 2, but the swapping instructions are handled differently. Consider the two numbers in the first line, X and Y. And the first number in the second line, Z. What first line? Are we talking about the swap lines here? Okay, I guess the swapping instructions, these are the swapping instructions. This is the first line. So this is X, Y, and Z. This 3 swap mechanism is used. The frequency in track X is sent to Y is sent to Z, and Z is sent to X simultaneously. All right, so 4, 8, and 5 all rotate. Then repeat the process using the second and third lines. Then repeat the process using the third and fourth lines, and so on. For the final line, Repeat the process with the final line and the first line. Finally, you'll need the test track frequency to verify your configuration is correct. Okay. All right, so we just do the following one and then just swap them all around. All right, this means that for part one, I'm going to need to redo the freaks here. Let's do this. Let part one equals freaks clone. Let's make it mutable. Change this to part one. Change this to part one. Make sure it's still 42.810 when I run it. It is. Okay, so now part two. We're going to do the swapping differently. Let's do this for I in 0 dot dot swaps len. That way we can increment by 1, right? We can say let x, y, and z are equal to swaps 0 dot 0, swaps 0 dot 1, not 0, I. Right, I, and then swaps of I plus mod swaps len dot 0. Right, that's x, y, and z. And now we just need to move x to y, y to z, and z back to x. So let's say let temp is equal to part 2 of z. Let's say let, part 2 of z is equal to part 2 of y. Part 2 of y is equal to part 2 of x. And then part 2 of x is equal to temp. Is that the right order? X is sent to y. X is sent to y. Y is sent to z. And then z is sent back to x. Yes. Okay. I think that's correct. And then we'll just print out our test index again. Oops. That was probably the harder way to do it, but there we go. What do we have? 39052. Is that the right answer? Yay. Okay. That wasn't too bad. Git commit -am problem 11 part 2. And what we got for part 3? It's getting a little better, but standard 2 isn't enough to meet the sirens. Your team members are starting to wander around. The crew is holding their heads and you're feeling a little strange. We don't have time. Program the earplugs to the highest standard quickly. Why didn't we start on the highest standard? Not even the captain can resist the sirens for much longer. It's up to you and your team to program the earplugs to the highest standard. A block is defined as a collection of consecutive tracks ordered by their track numbers in ascending order. The length of a block is the number of tracks in that block. Tracks 1, 2, and 3 form a block of length 3. 2, 3, 4, and 5 are a block of length 4. 2, 3, and 5 don't form a block because 5 is not consecutive to 2 or 3. Okay. All right, well, okay, let's just keep reading. To program the earplugs to the highest standard, use the block swap mechanism to execute each swapping instruction in order. For each swapping instruction, x-y, consider the pairs of same length blocks starting at tracks x and y respectively. Then choose a pair of blocks with the maximum length that don't overlap and don't extend beyond the final track. All right. The maximum length that don't overlap and don't extend beyond the final track. Then swap the frequencies of the first tracks in each block, the second, and so on. Okay. Consider this list. Swapping instruction 2-4 alters the list to this. Why? I guess we're swapping 2 and 4, and then 3 and then 5, and then we're done because we would overlap. This one I'm probably going to have to write a little test for because I'm not sure I completely understand. Choose a pair of blocks with a maximum length that don't overlap and don't extend beyond the final track. All right. Yeah, I might have to use test input for this one. All right, so let part 3 equals freaks clone. All right, and we're going to go through each of the swap instructions. And we're going to start at the beginning, starting at X and starting at Y. Okay. Actually, I can just do this, right? X, Y, and swaps. And now we're going to say while X is less than Y. No. I'm going to say for I in, and it's the maximum length that don't overlap. All right. 0 dot dot. What's the maximum length? Swaps len, I guess. That's the longest it could possibly be. If X plus I is less than Y and Y plus I is less than swaps len, right? As long as we're not overlapping. Oh, I don't know which order this is in. Let's make sure we get it in the right order. Let xy equals x dot min dot y, x dot max of y. Right, so this way we know that x is less than y, and we'll start at x and go all the way up to x plus I, such that I is less, x plus I is less than y, and that we didn't hit the end of the array. And then we'll just swap those two positions, right? Part 3, swap x plus I, y plus I. And then our final answer is just going to be the test index. Is that it? I mean, we can try it. I didn't like this because I have to dereference. Oh, is this? What is this returning? Oh, these are references to use size. Okay. I guess I can't do that. And these are also references. Okay. You know, I could just deref it here, right? Panicked. The length is 100, but the index is 100. But I checked to make sure that they weren't. Let's print out what we got. X plus I, Y plus I. I guess it's going to be, we're going to see it say 100. Yeah. What am I doing wrong then? Because I checked to see that Y plus I is less than swaps. Oh, swaps len, part 3 len. That's it. Okay. 62,364. If that's not the right answer, we're gonna punt to the test input. Let's find out. Ice Cold Witch says sooner or later there's going to be an AOC every month. I hope so. That would be a lot of fun. Hey, that's the correct answer. Okay. And what's the final? As your team member sends a program to all the earplugs, you feel something. You're regaining your consciousness. Seems like you did that just in time, too, as the captain was about to catapult himself off the plank. You can't hear any sirens now, so you're probably safe. Maybe you'll take that well-deserved nap now. All right, that was part 3.